Okay, so this is a classic optimization problem where you're trying to get the area for this pen to be as big as possible and yet still use only 680 feet of the wire fence. So the first thing we need to do is realize that we're trying to get the area function to be optimized, and the area of that rectangular pen is the length times the width, so we're just going to write x times y. The constraint that we have in this problem is that the amount of wire that we have is only 680 feet, and that's got to go for the two sides that are length x and the one side that's length y. And what that's going to do is allow us to get this area function in terms of only one variable, because what we can do is say y equals 680 minus 2x, and then we're going to take that and put it in for that y. So our area function in terms of x, just x, is x multiplied by y, which is 680 minus 2x. And if you want, we could go ahead and distribute that through and get 680x minus 2x squared. And what we're trying to do is get the biggest value of this function for any given value of x. So the first question they ask is about the domain, or basically what x could be. And the two scenarios would be, you could have x be virtually 0, just big enough so that you would have some width to this thing, and have a really, really long pen, so y would be really big. Or you could have x be really, really long and it be skinny like this. So if that were the case, with an x on this side and x on that side, two x's would essentially have to be just less than 680 feet. So that means one x would have to be less than 340 feet. So I would say the domain for this is 0, 0 for x min and 380 for x max. I'm sorry, 340 for x max. But we could do the area as a function of x, y. We could fill in that question. It would just be x times y. And the area as a function of x, which would be 680x minus 2x squared. And so if you think about this function, it's going to be a parabola, an upside down parabola, because it's an x squared guy. So the graph is going to kind of look like this, where it's going to go up and max out and then come down. So what we're looking for is that area to have its highest point. And the way we find that is by taking the derivative and setting it equal to 0. So the derivative of this thing is a prime of x, which is going to be 680 minus 4x. And so that's going to be set equal to 0. That triple equal sign means we're setting it equal to 0. So add 4x to both sides, and you're going to get 4x equals 680. And divide both sides by 4, and you get x equals, let's see, 4 goes into 6 once, 2 left over, 28, 170. So x equals 170 is a critical number for this thing. So that means it's a place where the derivative is equal to 0. Other things that are critical numbers are places where the derivative is undefined. That would be like if a denominator was equal to 0. And so that's, I'm going to tell you, that's going to be the place that's going to turn out to give us the maximum area. But we'll see what the rest of the questions ask here. So down here it says determine the absolute max value of a of x over the closed interval from what we have is 0 to 340, and check the value of the two endpoints and the critical values. So basically, the area when you evaluate it when x is 0 is going to be 0. So in other words, if you plug 0 into the area function over here, you're going to get 0. And that makes sense because that means we would have literally no width to our pen. Our critical value is 170. And when you plug 170 into our area function, you get 680 times 170 minus 2 times 170 squared. And that quantity turns out to be, if I did it on my calculator correctly, 57,800. And then again, they ask you for the value at the maximum x value, which is 340. And if you plug 340 in here, again, you're going to get 0. 340 times 2 is 680, and 680 minus 680 is 0. So you're going to get 0 there as well. So we get 0 at the minimum, 0 at the maximum x value, and we get 57,800 as our max, as our value of the area at the critical value. And so that's our winner. He gets the biggest area by far. And so all we have to do now is get the dimensions of the pen with the largest area. So it's going to happen when x is 170, so we can put 170 in here. And then as far as getting the y value, all you have to do is do 680 minus 2 times 170, which is 340. And that, of course, is 340. So 340 for y. And you may notice that what we've got is a rectangle that is twice as long as it is wide. And that's because we had this other side used up for the river, so we didn't really need to use that. Had that not been a restriction and they just said we want to make a rectangle with 4 sides with the most area with 680 square feet, or with 680 feet to use as the perimeter, all you would have turned out is you would have gotten a square. That's the most efficient way to make a rectangle with the largest area. But it's kind of a classic problem, like I said. They'll usually have a river over here, or maybe his barn is over here, or something like that, where he only needs to use 2 sides. But that ought to do it. So, and the maximum area of the pen, I guess we need to finish that, is also 57,800. So that should do it. Good luck.